This is Mrs. Denton, the 8th grade Pod A math teacher. This year we're going to be uploading videos of our math lessons in case you are absent, in case we transition to distance learning, or just in the case that you want to review the material, study and prepare, or look back over the vocabulary to make sure you have everything in your notes. Extra help, extra practice, that's what the purpose of these videos are. Mrs. Freeman, the 8th grade Pod B math teacher, will also be posting videos. We'll actually alternate creating the videos for your class. This first lesson is Lesson 1-1, Evaluating Algebraic Expressions. We will be taking notes every single day we do a lesson so that you will have this material with you. So if you want to get out a blank sheet of notebook paper, and for your heading at the top of that piece of paper, you want to write Lesson 1-1, Evaluating Algebraic Expressions. You can include the date if you would like. It's important for you to include the title and keep your notes in order for reference, so you can use these as examples if you want to go back. Prepare for our test, our quiz, review your material, seeing it, hearing it, rewriting it maybe. All of those are ways to retain information better. After you have that labeled, we're going to start out with a warm-up for the day. And you're going to notice that it says evaluate the expression. And as you look through these 6 problems, you may notice that there are parentheses, there are exponents, there are operations that may vary as well. Think about your order of operations. I'm going to pause for a few seconds. You can also pause the video until you finish, and then we'll come back and see how well you did. Okay, let's look at problem number 1. We do have a set of parentheses, and inside those parentheses we have 25 divided by 5. When you're thinking about the order of operations, remember parentheses or grouping symbols are the first steps that we need to take in solving an expression. So we're going to take this problem here in the parentheses, and we're going to go ahead and solve that, leaving us with 5. We bring down the plus 32. And now we are given a total of 37. Okay, let's look at problem number 2. Again, we have a set of parentheses. So those grouping symbols need to be completed first. And we can actually put in 50 divided by 4 into our calculator. We know that's going to end up being a decimal. And that decimal is 12.5. We bring down the first part of that, 142. And once we add 12.5 to that, we are given 154.5. Okay, number 3. Number 3 has a little bit more going on. I see 2 sets of parentheses. I also see an exponent. So thinking about our order of operations, we're going to work with those grouping symbols first. And you can start from left to right, just like you do when you move on to the multiplication, division, addition, and subtraction with order of operations. So if I multiply 22 by 16, I'm going to get 352. And before I simplify those parentheses on this right side, I'm going to go ahead and solve that exponent. So 5 taken to the second power, or 5 squared, is the same thing as 5 times 5, which is 25. I'm going to add 25 to 7. And I'm going to get 32. Bring down our division. And when we divide 352 by 32, we should get 11. Okay, number 4. Again, we have two sets of parentheses over here on the left side and over here on the right side. Within those parentheses on the left side, I have some exponents. 2 raised to the third power, or 2 cubed, is the same thing as 2 times 2 times 2. And that gives us 8 plus 2 squared is 4. And I can go ahead and simplify that into 12. Over here on the right side, I have negative 14 plus 32. I can think of that as the same thing as 32 subtract 14, leaving me with a positive 18. And I can bring that down to the 12 that I already simplified. And 12 add 18 gives us 30. Now for number 5, we have 9 squared subtract 5 times 12. So when we're working out with this, we can think of our exponents and then our multiplication. So 9 squared is going to give me 81. And then I'm going to multiply 5 times 12. And I get 60, and 81 subtract 60 is 21. Number 6. Number 6 is a little different than the other problems because if you notice there are grouping symbols, but there's also an exponent outside of the parentheses in this example. So one of the 7th grade concepts tells us that it does matter where my exponent is located, if it's within or outside of those parentheses. So let's go ahead and take care of this first part, these grouping symbols here. I have negative 125 divided by 25. If I'm thinking about quarters or groups of 25, how many groups of 25 are in 125? Okay, 4 make 100, so put one more in there, 5. So I have 5 groups, and a negative divided by a positive leaves me with a negative 5. I'm going to bring my multiplication sign, and over here I need to remember that this means negative 13 times negative 13 because of the location of my exponent. That's actually going to give me a positive 169. So now I'm going to take negative 5 and multiply it by positive 169, and I get negative 845 as my final answer. Okay, the next slide we have vocabulary. When we're talking about algebraic expressions, we need to remember that an expression, the key word here, an expression is different from an equation, an expression that may contain numbers, operations, and one or more variables. So that's what makes it algebraic, because we're working with variables. So we're going to see numbers, operations, and one or more variables. Okay, moving on to example 1. Our first example says to evaluate each expression for x equals 8. So if we know that x equals 8, we're going to substitute an 8 in place of x anytime we see that in our problem or in our expression. So let's look at part A over here. I have my x, so therefore I'm going to substitute my 8. Now this also has absolute value lines around this first part. think about these as grouping symbols, just like you would parentheses. So I'm going to go ahead and, I think I'm going to switch this color here, and I'm going to substitute 8 in place of x, making sure that I continue using those absolute value lines and bringing down the remainder of that expression. So the first part of this is my grouping symbol, and I'm going to keep those absolute value lines with my answer of -4, and I'm going to continue to bring down the +2. Now, when we're talking about absolute value of -4, we're measuring the distance on a number line that -4 is from 0. So if I started at 0 and I moved to -4, I would have moved 4 units. If you'll remember, we can't measure distance in negative values. That's why a lot of us remember that absolute value is always positive, because that's how we measure distance. So the absolute value of -4 is +4, and then we're going to add 2 to that, and we're going to get an answer of 6. Okay, the expression in B, we see a radical symbol. Our x is within the radical beside a coefficient of 2. So when I substitute my value of 8, I'm going to put those parentheses around that value I'm substituting, and notice I'm going to keep it underneath the radical. Then I'm going to bring down my subtract 3. Now, our radical is again considered a grouping symbol, so I'm going to simplify that part first. And I'm going to take 2 times 8, and I get an answer of 16. Radical 16, subtract 3. Or I can also say the square root of 16. The square root is the opposite of squaring a number. So think about, what number would I square to get an answer of 16? 4, that's correct. So the square root of 16 is 4, subtract 3, and we're going to be left with an answer of 1. Okay, example 2. Evaluate each expression for x equals -3 and y equals 4. Okay, in A, we have 2x plus 3y. So I'm going to substitute a -3 in place of x. Anytime I'm substituting a value, I want to go ahead and include that inside the parentheses. If I get into the habit of doing that, it's going to make solving, substituting answers with, or values with, exponents a lot easier. Now I'm going to substitute 4 in place of y, and I have a new expression, 2 times -3 plus 3 times 4. And I'm just going to simply work from left to right on my multiplication. So I'm going to take 2 times -3 plus 3 times 4. Now I have -6 plus 12, which equals 6. On B, I have a fraction bar. A fraction bar is also a grouping symbol. I'm going to substitute a -3 in place of x. I'm going to substitute a 4 in place of y. And I also have an x in the denominator. Now notice x is being squared. So I need to pay attention to that when I'm substituting a negative value. So I want to include my -3 inside parentheses, and I'm squaring that, -3. So I can simplify the top and then the bottom. -3 plus 4 is 1. My denominator, -3 squared, or -3 times -3, is going to give me a positive 9. When I'm working with fractions as my answer, I need to ask myself, can this fraction be simplified? 1/9 is in simplest form, so therefore it is my answer. Okay, example 3. Now we're going to evaluate each expression for a equals 2/3, b equals 9, and c equals -4. In A, we have a set of parentheses, we have I see an exponent, we have a coefficient of 2 out here. So let's go ahead and start substituting for each of these values. Whoops. So I'm going to use 2/3, 9, and -4 when I substitute. So I also need to remember, include the 2 out in front. Sometimes we forget that. Now I know when I substitute, I'm going to be putting in parentheses, and I also have parentheses. You have two options here. You can continue using a set of parentheses within a parenthesis. You can use a set of brackets. I'm just going to continue with my parenthesis, and we have a 9a squared, so I'm going to substitute the 2/3 in place of a and make sure I'm showing that that's squared. I'm going to subtract 2 times b, which is 9, plus 3 times c, which is -4. And those in parentheses. Now I'm simply just going to work from left to right, working out what I need to do after I solve this part right here. So 2/3 squared, I'm looking at 2/3 times 2/3. So now I have 9 being multiplied by 4/9. Subtract, and I'm going to go ahead and simplify this. 2 times 9 is 18. And over here, I'm going to go ahead and simplify this. Now, there's something else that I want you to notice about this last part. Notice I went ahead and put plus, and then this gives me a -12. In algebra, rather than writing a plus -12, we're going to simplify this as to a subtraction problem. Okay, now we're going to go back from left to right solving here. If you'll remember back in 6th grade math, when you multiply a whole number times a fraction, you can simply put that whole number over 1. And anytime you're multiplying two fractions and you can simplify those diagonal values, go ahead and do that. Then I'm left with 4 over 1, which simplifies to 4. Subtract 18. Over here, I'm going to write that as -12 because adding a negative number is the same thing as subtracting with integers. Now I can go from left to right. 4 subtract 18 is -14, and -14 subtract 12 is -26. And I bring that 2 down, and 2 multiplied by -26 is going to give me a -52 as my answer. Okay, let's look at B. B, we have a radical symbol, and we're substituting 9 inside of that radical. So I'm going to go ahead and substitute there. Subtract 3 times a, and a is my fraction, 2/3, plus 2 times c, and c is my -4 value. Now I have parentheses, but those are just because I'm substituting. I have a radical, that's a grouping symbol. Let's go ahead and simplify that. What number times itself gives us 9? And that's 3. Subtract. Okay, remember I can turn that into a whole number. 3 over 1 times 2/3. Those 3's simplify to 1's, leaving me with 2 over 1, which simplifies to 2. 2 times -4 is going to give me a -8. So I can add -8 or I can simply subtract 8. 3 subtract 2 is 1. 1 subtract 8 equals -7. Okay, example 4. We have a word problem here. Some of us get a little anxious when we see a word problem. Remember, use your tools to break it apart into smaller pieces, mark it up, underline, circle, anything that you see that is important. Our example 4 says you want to tile a 10-foot square floor with tiles that are twice as long as they are wide. Determine how many tiles you need to cover the floor when the tile length is 2 feet. So some important information here that we may want to mark up. A 10-foot square floor, tiles that are twice as long as they are wide. And the last part that's asking us, or actually telling us what we need to determine, says determine how many tiles you need to cover the floor when the tile length is 2 feet. So some important parts there that we want to be looking at. Now, I'm a very visual person, so it helps if I sketch out a picture. So when I see this 10-foot square floor, I'm looking at a square, and I know it is 10-foot square floor, so 10 by 10. And that tells me something else about this floor. That tells me that the area of this floor, length times width, is 100 square feet. Now, I also need to think about the tile length. The tile length is 2 feet. Now remember up here it says that in that first sentence that the tiles are twice as long as they are wide. So these tiles would be 1 foot wide. So that tells me the area of the tile is 2. So if I know I have an entire floor or a total area equal to 100, and I know the area of my tiles is 2, then I can break that into a division problem and know that I need how many tiles to cover that floor. Yes, 50. So my final answer for this word problem would be you need 50 tiles. Now, notice how I drew pictures. I labeled things. I went ahead and worked out the parts that I knew to be able to solve the problem. There are many other strategies you could use to solve this example of a word problem. Okay, example 5. Example 5 is working with non-standard operations. And it says evaluate the expressions using the non-standard operations. And we've got this non-standard operation and this non-standard operation. Now look at this right here. This symbol is what we're going to use when we are working with a non-standard operation. So if I look at A and I notice that the symbol in between the 2 and the 4 is the dot, then I'm going to refer to this operation right here. Notice that I basically have a 2 in place of the A and a 4 in place of the B. Those are the values I'm going to substitute. And then I'm going to use this second part as my expression. So I'm simply going to substitute a 2 in place of the A and a 4 in place of the B. And you can put parentheses around that if you need to. Go ahead and solve this multiplication. And we have 4 plus 4 equals 8. Okay, the next one, B. Notice we have, again, this symbol right here, but we also have 2 of those. So this one's going to have an extra step after we do the first step. The first step in part B is similar to A. So I'm going to substitute 3 in place of A, and I'm going to substitute 5 in place of B. So then I would have 2 times 3 plus 5. Now notice this is just going to be my first step in this problem because I'm only solving this first. So I have 6 plus 5, which equals 11. Now I'm not quite finished yet. I'm going to take 11 and take it a step further. So now this first part was 11. I'm going to take that non-standard symbol and then I'm going to bring down the 2. And again, I'm going to substitute this for A and this for B. So I go back to that expression, 2A, or in this case, 2 times 11 plus 2. Simplify, 2 times 11 is 22, plus another 2 gives me 24. And that would be my final answer. Okay, let's do C. Now notice in C, we have this non-standard operation, and we've also thrown in the other symbol now. So we're going to have a multi-step expression here. In the first part, I basically have my A and my B. So I'm going to substitute those in place. 2 times 3 plus, and B is going to be my 5. So go ahead and simplify this. We get 6 plus 5 equals 11. That is the first part. Now I'm going to take that 11 and I'm going to make the second part symbol, the non-standard symbol, and then substitute my 2. So this 11 now becomes my A and 2 becomes my B. So I'm going to take the operation over here and I'm going to substitute 11 in place of A, fraction bar, and I'm going to substitute 2 in place of B. And now I'm simply going to solve my expression. So 2 groups of 11 is 22. Divided by 2 simplifies to 11. Okay, you try. You can actually pause the video at this point. And then once you've had time to try these 3 problems, you can come back and look and see how you did. So if you want to go ahead and pause the video and then come back and check your work. Okay, number 1 says evaluate the absolute value of negative 3x plus 7 given x equals 6. So we are going to take x equals 6. and we're going to substitute that inside of our absolute value. So I have the absolute value of -3. I'm going to substitute, sorry, that's supposed to be a parentheses, 6 in place of x plus 7, and then my absolute value line. And I'm going to complete the order of operations within those grouping symbols or absolute value lines. -3 times 6 gives me -18 plus 7. Absolute value lines, -11. And the absolute value of -11 is +11 because -11 is 11 units from 0. I cannot have an absolute value as my final answer. I must simplify it. Okay, let's look at number 2. Number 2 says evaluate -2 parentheses radical a plus 4b subtract 3, given a equals 16 and b equals 3/4. So I'm going to start substituting from left to right. I've got my parentheses there. I'm going to use my radical and find the square root of 16 once I substitute, plus 4, and b is going to be 3/4 when I substitute that value, subtract 3, end parentheses. Now I'm going to work within the parentheses and go ahead and simplify these. The square root of 16 is 4. 4 times 3/4 simplifies to 3. And then I'm simply going to bring down my -3. Now I can go from left to right within the parentheses. 4 add 3 is 7. 7 subtract 3 is 4. Now I have -2 times 4, and that gives me -8. Okay, number 3, the cost for A, adults, C, children, S, seniors to attend a concert is given by the expression. What is the cost for a group of 2 adults, 5 children, and 4 seniors to attend the performance? So they've given us the expression in number 3, and they've also given us the values to substitute. So I'm going to replace A with 2. So I've got $12, and I want 2 of those for 2 adults. The cost for children is $7.25, and we've got 5 children attending. And the cost for a senior is $9.75, and we have 4 seniors attending. So once I substitute my values in place of those variables, I can do my multiplication, and then I can combine with addition. So 2 groups of $12 is going to give me $24. And 5 groups of $7.25 is going to give me $36.25. And 4 groups of $9.75 gives me $39. Now I'm going to add those amounts together, and I'm going to get $99.25. Now, in the context of this example, we're talking about cost. So our units would be a money unit, which is a $sign. And I'm going to say the cost for this group is, and I'm going to include my units, $99.25 in my end mark. Remember, your $sign comes before the numerals.